Okay, question 20. In my marking, I didn't see many people get close to this question, so really going to try to work out why that is and talk you very carefully through this question. A large carton of orange juice contains 4 litres of juice to the nearest 10 millilitres. Okay. A factory uses the large cartons to fill individual cartons that are 5 centimetres by 6 centimetres by 3 centimetres, all to the nearest millimetre. Okay. Then we're given as well that 1 centimetre cubed equals 1 millilitre. That is just a piece of information. Okay. Show that the maximum number of cartons that could be filled by the large carton is 46. So the maximum number of the small individual cartons could be filled by that is 46. We need to show that. So the key thing is to work out what kind of question this is. And it's a limits question. And I should be clued into that by the fact that it's constantly talking about the nearest and the maximum number and to the nearest. You know, it's a limits question. So I need to think, how can I fill the most number of these small cartons? Well, to fill the largest number of small cartons, I'd want the biggest amount of juice. So this needs to contain 4 litres of juice, but to the nearest 10 milliliters, so it could be fractionally more, and we'll look at that in a moment. But I want the most juice I possibly could get. And I'd want these cartons to be as small as possible. If I'm going to fill loads of them, then I want the most juice fitting into a lot of small cartons. So these ones should be as small as possible in order for me to work this out. So it's going to be the largest amount of this divided by the smallest volume of this. So the largest volume of or capacity of juice in this divided by the smallest volume or capacity of this one will give me the greatest number. So 4 litres, okay, equals 4,000 millilitres, which you should know. I'm sure you do know. So to the nearest 10 millilitres, so the maximum possible. Okay, remember, with limits like this, where it's continuous data, my maximum possible here that I'm going to use to calculate is 4005. Anything that is actually 4005 or higher will round up. Anything lower will round down. And the reason why I use 4005, even though you're used to it rounding up, is it's continuous data. You would never actually get 4005 millilitres because there would be a few atoms either way. You know, you couldn't possibly ever actually have 4005 millilitres, so I can use that. And it's typical in these limits questions that I would. So that's the most possible orange juice. Now I want the smallest possible cartons in order that I can fill as many as possible. So each of these are 5 centimetres, 6 centimetres, 3 centimetres to the nearest millilitre. So the small cartons for them to be as small as possible, firstly I'm going to convert them to millimetres. So they are 50 centimetres, okay, by millimetres, 60 millimetres by 30 millimetres. But they're not exactly that. They could be a bit more or a bit less. They are that to the nearest millimetre. So they could be the smallest possible, the minimum possible would be, if it's the nearest millimetre, they could be as low as 49.5 times by 59.5 times by 29.5. That would be my lowest possibility. So let's do that and see what the lowest possible value would be. So 49.5 times by 59.5 times by 29.5 equals, okay, so equals 86,884.875 millimeters cubed. Okay. So, let's see where we're at then. So, if I've got this 4,005 milliliters, now 1 milliliter equals 1 centimeter cubed. Okay? So, 4,005 milliliters equals 4,005 centimeters cubed. Now, you've got to be careful here with the, because in order to work with these, they need to be in the same sort of units. Now, this is in millimeters cubed, and I'm going to convert it to centimeters cubed. Now, just to be really careful with that, let's look at, when you're converting between volumes, you kind of want to divide this by 10, don't you? Because this is millimeters, and you're going to turn it into centimeters. But that's not enough, and I will explain why with a little diagram. So here's my 1 centimeter cube. I did this in a previous paper. So this is 1 centimeter by 1 centimeter by 1 centimeter, which is 1 centimeter cubed. Now the exact same cube with millimeters would be, so this is my exact same cube as that one, but I'm just going to label it differently because it's 10 millimeters by 10 millimeters by 10 millimeters, which is 1,000 millimeters cubed. Okay, so I can actually see that to convert, I actually need to divide by 1,000 here. So 86,884.875 millimeters cubed equals 86.884875 centimeters cubed. Okay, and now I've got the information I need, so I can just divide this maximum amount, maximum amount of orange juice by the minimum possible size of the cartons. So I'm going to do 4,005 divided by 86.884875, and that will give me, I've got that, I'm going to divide by, here's my 86,884.875 millimeters cubed. To convert to that centimeters cubed, I need to divide by 1,000. That gives me that. So that's in my memory as part of the answer. So as the answer, so 4,005 divided by that last thing that I had gives me that, which is 46.095. So what that means is I can fill at least 46, fractionally over 46 cartons. I've shown it. I can fill just over 46 cartons. There's nothing to put in this answer, but you're showing, so that's that done.